this class actually. So Golem's question is, what day is the final? So let me type in here. I'm going to put on Blackboard, okay? So May 12th is our last day of class. So what we could do is we could have our final on this day. So Fu Jun's question is, will homework 20 be our last homework? Yes. Well, it doesn't mean you don't have to do, it doesn't mean you don't do the homework anymore, right? You still have to do the homework. Only for grading policy. For grading policy, if you finish 20 homework sets, you are done. You get 100, all right? Can we do a later day for the final, Paul? Yes. So we do later day for the final. So we will wait for the department announcement. So they should give me, the final days. They should give me the final. Oh, actually, you know what? Because the final is in person, I have to wait for them because they need to assign me a classroom. They need to assign us a date, a time, and a classroom. So there will be a time, we meet each other. So final is in person. Last class, okay. So, but let me take it back. Golem, I said we could do final on May 12th. That's wrong. Okay, we couldn't do that. We couldn't do it because we have to wait for the departmental announcement. So the office, the math department will give me the date, time, and the classroom because the final is in person. We have to meet at the campus to take the final. So as soon as I get the date, time, and classroom, I will post it on Blackboard. Right, James, I don't have the final date yet. I do not have it yet. I will give you a final exam. Okay, actually, let's see. Because I want you to focus on your homework, right? I want you to, so basically, the final will not be departmental. The final, so I make the final exam. So I will pick from the homework sets. Maybe I give you, maybe I give you a couple of numbers. It's like section 1 point something. You review a couple of questions. Okay, I'll make a smaller sets of the homework so you could study, you could focus on it. Let me see anything else. Okay, Woodley is asking, can we do a review of the practice of the sample questions for final on Blackboard? Yes, we could do that. Could you go over 175 from homework? Yes, let's do that. So 175. On 6.4. Okay. So in the following exercise, use appropriate substitutions to write down the Maclaurin series for the given binomial. So 175 is 1 plus x squared raised by negative 1/3. So let's write down, let's go to the whiteboard. Let's first think about, I better use this to write it. Okay, let's go to power series, right? We used to have a Cn, let's just review a little bit. X minus a raised by n, and n we want to go from 0 up to infinity, right? And then later on, the book proved Cn is related with the differentials of the function we're talking about. Just seeing, okay, if we can focus on the function, we see that's f. So nth order of derivative evaluated at the center A divided by n factorial x minus a raised by n, right? So basically, we come from power series right, to Taylor series. Then what's Maclaurin series? Maclaurin series is saying a equals to 0, right? Maclaurin series. So let's just read one more time. Maclaurin series is, and start from 0 up to infinity, f n of a. What's a? 0, right? Maclaurin series is a subset of Taylor series. N factorial x raised by n, because a is just 0. So Maclaurin series is a Taylor series centered at 0. Now we're given this function. So this function is what? 1 plus x squared. So of f of x equals to 1 plus x squared raised by negative 1/3. Right, that's our function. So what do we have to do? We just need to find derivatives. Right? We just have to find the derivatives. So first, so we need to find f of 0. F of 0 will be first term, a naught, right? So f of 0 equals 1. F prime of 0. We'll take a derivative first. When we take a derivative, we get negative 1/3 of 1 plus, what is this 0x is 0, right? It's just 1. Why 1 raised by any power? Just 1. So first derivative, I better write the function too. So f prime of x equals to negative 1/3 of 1 plus x squared. Oh, I'm missing something. Or actually, f prime 0 is 0. Raised by, well, negative 1/3 minus 1, negative 4/3, right? Then we have to multiply the derivative by chain rule, the derivative outside. So that's 2x. So multiply by 2x. This becomes negative 2/3 of x times 1 plus x squared raised by negative 4/3. So f prime of 0 is just 0, right? Because we have x here. And when we take a second derivative, f of second derivative, negative 2/3 of, well, we could do by chain rule, right? No, by product. product rule. So we think x times 1 plus x squared raised by negative 4 over 3 is product of two functions. So derivative of x is just 1. So we get a 1 plus x squared raised by negative 4 over 3, right? That's f prime of g times g. Then plus, I better put a parenthesis here, plus, now I'm keeping f, I'm taking g prime. So g is 1 plus x squared raised by negative 4 over 3. So multiply by negative 4 over 3 times 2x again, right? By chain rule 2x, I'm just write x here. Then negative 4 becomes negative 8 times 1 plus x squared raised by negative 4 over 3 minus 1, negative 7 over 3, right? We can simplify a little bit. Oh, that's the equal sign. We don't have a, let's not simplify, because what do we get? We get f double prime of 0. We just plug into 0 into this double prime. The x term is 0. So the first term, we have two terms here, right? The second term is 0 because we have an x here. 0 times anything will be 0, so the second term disappears. But the first term survives. We have negative 2/3 multiplied by, just multiply by 1. So negative 2/3, right? Negative 2/3. Then we can keep going. So we can keep going. So the question asks us to do what? To write how many terms? Oh, write Maclaurin series. Now, you know, so we better do more so we can find the patterns of Fn. Let's do more. More will be, there will be a lot. Let's see. So negative 2/3. When we do this, we get negative 2/3 multiplied by 2x multiplied by negative 4 over 3. When we plug into 0, that will be 0, this term. Then product rule again, so just one term survives. Right, one term survives. So let me just write a couple of terms. So I won't be able to, so let's use this. So this equals to, oh, let's not use this. So the first term is f of 0, right? Just 1. 1 plus, the second term is 0, right? F prime of 0, 0 times anything will be 0. So we don't have x raised by first power. But we do have x raised by a second power. So second power, we would have negative 1/3. Because we have negative 2 over 3 divided by 2 factorial. Right? Negative 2 over 3 divided by 2 factorial. 2 factorial is just 2. So we get a negative 1/3. Negative 1/3 x squared. Right? So this is the only first two terms. First two terms. Then you keep going. You find f triple prime. You evaluate at 0. Then you find f fourth prime. So ideally, you can find a pattern. Then you'll be able to write nth term in a notation. All right. But I don't want to do everything here. So who asked this question? Paul. Paul, does this help? So the job is to take derivatives. The answer key for 175 has that term with r times n in it. R times n, r raised by r on top of n. R over n, you mean? Where does r come from? Oh, R choose N. Okay. Ali, R choose N. That makes sense. R choose N. All right. That's something else. Oh, okay, okay. Okay. That's an even better solution. Right. Actually, thank you for, let's see, who's this? Ali. Yeah, Ali, thank you so much. Thank you very much. Actually, let's see. Actually, okay, we have, so we go one step further actually. Let me see. If I erase, I will erase everything. I don't want to erase everything. So let me just write on the side. Let me write here. So I was about to go to review that. Okay, so come from power series. The power series, we derive the Taylor series. You know, Maclaurin series is just special case of Taylor series. Now we have something called a binomial series. We have two terms, which means we have two terms. And then we can prove this. So go one step further. We have this combination. R choose N of x raised by, what was the notation? The first one raised by N, actually, let's do this. Okay, so for our case, you see we have this is A, this is B. So basically, so binomial is A plus B raised by N, right? So raised by N. So in our case, it's 1. A is 1, B is x squared. So in this case, x goes to ascending order and not x, A. So let me not see this equal sign, okay? Let me not see this equal sign. You know what, let's go back to book. Okay, otherwise I'm going to use all those different notation. I'm going to confuse you. So I was about to review this anyway. So binomial series. Let's just review. Then probably everything becomes easy for you. You see this? Okay, so binomial series. So we have this is called a combination. So out of R things, choose N. So think about this. So what is this? Just let's make sure we understand this. So let's see, we have 5 apples, right? That would be R. So let's see, R equals to 5 apples. Now, we want to choose 2 apples out of these 5. So what does R choose N mean? What does 5 choose 2 mean? So if we put a parenthesis 5 on top, 5 as R, N as 2, that means out of 5 apples, we're choosing 2 of them. So this notation, out of R choose N or out of 5 choose 2, is called how many ways. So how many ways we can do that? So think about it. We have 5 apples, right? We have 5 apples on the table. Now, out of these 5, we randomly choose 2. How many ways of doing that? So that's this one, this many. So if we do the calculation, we would have 5 factorial divided by 2 factorial divided by 3 factorial. Right. So that would be 5 times 4 times 3 factorial divided by 2 factorial divided by 3 factorial. So 3 factorial divided by 3 factorial is gone. 4 divided by 2 factorial is 2. 4 divided by 2 is 2. So 2 times 5, 10. So that means, you know, 5 apples on the table. If we choose 2 of them, we have 10 ways to do that. So there are 10 ways to choose randomly chosen 2 apples from the 5. So that's this notation. So it's called R choose N. How does that make sense? Okay, so Ali, thank you. R choose N. Nope. Oh. All right. But for this case, R is non-integer. It's a non-negative integer, okay? R has to be 0 or positive integers, for this. Okay, for this. We didn't, so last class, we were not able to do one example with R is not an integer. So with R integer is easy, right? If R is 0 or integer, positive integer is easy. We just do this, R chosen N, right? So up to R, so N starting from 0 up to R, X raised by N. So this is just a notation of binomial. So this is just binomial theorem. It's not binomial series yet. This is a binomial theorem. Okay, so let's see this one. So 1 plus x raised by 5, we have 5 choose 0, the first one, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5, right? So how do we get a 1x, x squared, x cubed, x5? We have 2 things here. We have a plus b. So a is 1, b is x. So the first one goes ascending order. Goes ascending order, or goes descending order. The first one goes descending order. But because here is 1, right? 1 raised by 0 is 1, 1 raised by 5 is 1, 1 raised by anything will be 1. But the second one goes ascending order. So b goes ascending order. So in the first one, it's b raised by 0. So x raised by 0, which is 1. Then x raised by 1, x raised by 2, x raised by 3, x raised by 4, x raised by 5. All right. If we do calculations, we get this. We get 1 plus 5x plus 10x squared plus 10x cubed plus 5x4, x raised by 4 plus x raised by 5. So this is just a binomial theorem. So now we want to use this binomial theorem for binomial series, which means we want R to be any real numbers. It can be negative, it can be positive, it can be 0, it can be a fraction, it can be irrational numbers. All right. So binomial series, the idea comes from binomial theorem. So to do this, we see this pattern. So the book calculated for us. So f of x equals 1 plus x raised by r. F prime of x equals r times 1 plus x r raised minus 1 by power rule, right? Power rule for derivatives. So when we plug in 0, that's why we're talking about Maclaurin series. F of 0 is 1, f prime of 0 is r, f double prime is r times r minus 1, da 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 da. F, nth order of derivative of f equals r times until r minus n plus 1. And we can write this in another case. How do we write that in another case? So now we have this. So this can be derived. So the Cn was nth order of derivative, evaluate at center, divided by n factorial. Well, for our case, this center is 0. It's just this. It's just r times r minus 1 until r minus n plus 1 divided by n factorial. Right, so this was new for us from last class. So what is R choose N? R choose N is just this. Right, so this formula. So with this notation, now we can write the binomial series. for 1 plus x raised by r, for r is any real number. Can be negative, can be fraction, can be irrational numbers. So how do we write it? We write this way, right? Out of r, choose n, x raised by n. What is that? It's just 1 plus rx plus r times r minus 1 divided by 2 factorial x squared, so on and so forth. So that one, so 1 plus x squared raised by negative 1/3. Yes, 1 plus x squared raised by negative 1/3. We just apply this. Just apply 6.9. All right. Does this make sense? Paul? The calculation may be weird. Let's see an example actually. So actually, let's finish this one. So this says, okay, with this notation, we can write binomial series for 1 plus x raised by r, for r to be any real numbers. And then we have this series. So to determine the interval of convergence for binomial series, we apply ratio test. Then we do absolute value of n plus 1 term divided by n term. So what do we get? In this case, we just get this. So we want the ratio, but the ratio test says, okay, we want to be less than 1, the x value to be less than 1. So this converges, the binomial series converges only when absolute value of x less than 1 for this case. So that means the binomial series converges, the interval of convergence is from -1 to 1. Then we can check at the endpoint, -1 and 1. At the -1, when x equals to 1, it converges, right? So we can change that one. So at 1, it converges. At the -1, it diverges. Right. So that's this example. Let's see the definition one more time. So for any real number r, the Maclaurin series for f of x equals to 1 plus x raised by r is the binomial series. It converges to f for absolute value of x less than 1. And we write like this. 1 plus x raised by r equals to the summation notation. Expand, we get 1 plus rx plus r times r minus 1 divided by 2 factorial x squared, so on and so forth. Same as 6.9 for absolute value of x less than 1. Okay. Now let's use this definition to find the binomial series for this example. We were not able to talk about this last class. That's why, so I assigned the homework too early. So let's see this example, finding binomial series. So A, find the binomial series for the function square root of 1 plus x. So what's r in this case? R in this case equals to half, right? Then use the third order Maclaurin polynomial P3 of x to estimate square root of 1.5. Then use Taylor's theorem to bound the error, which is use a graphing, okay. We don't care about the second. Let's just focus on the first one. We want to find a binomial series for this function, and then we want to use P3 to estimate it. Estimate the square root of 1.5. So in this case, r equals to half, right? So we just use the definition. So get a 1 plus rx, well, half x, plus half times r minus 1, the half minus 1 is negative half, divided by 2 factorial, right? Then half times half minus 1, right? times half minus 2, then divided by 3 factorial, so on and so forth. Because we only want to do P3, so we'll end up at this 3. So we simplify, we get a 1 plus half x minus 1/8, right? Or we can write as 1 over 2 squared times 1 over 2 factorial. So because we want to find the pattern. We want to find the pattern. Then simplify the third one. We see that's positive term, because negative times negative become positive. We keep 1 over 3 factorial. Now we see 1 times 3 in the numerator and the 2 raised by 3 in the denominator. Right? Then we can see the pattern is -1 raised by n plus 1, because the first one is positive. That's why we do -1 raised by n plus 1, because 1 plus 1 is 2, -1 squared is positive, because the first term is positive. Or divided by n factorial, because the second one, then multiply by this term, right? So this one we see the first term is 0 factorial, the second one is 1 factorial, 2 factorial, 3 factorial, right? So n factorial, because this here n start with 0. Then this part gives us 1 times 3 times 5 times 2n minus 3, all the other numbers, divided by 2 raised by n. Right? We see this is 2 raised by 0, 2 raised by 1, 2 raised by 2, 2 raised by 3. Sometimes it's not easy to see this pattern. For this one, actually, we have to do more to see this pattern, because 1 times 3 times 5, maybe just do 2 more terms. But in any case, we just trust this book. Where did the 5 comes from? Well, the 5 comes from assumption. All right, that's why I was talking about it's better to do more terms. To do, the next term should be 1 over 4 factorial, 1 times 3 times 5, then 2 raised by 4. We should do one more term, then we will see the 5. In this case, the book just didn't do that. So then we can write this one in general. We can write as 1 plus, this. So this is an an term, right? Of course, with x raised by n. All right. So the key is just follow the formula, follow the definition, right? Follow this definition. So R can be, for this combination to R to be a real number, fraction, it's difficult to think, 5 choose 2, right? So think about this. This is a half choose 5, half apple choose 5 of them. It doesn't make sense, right? It doesn't make sense. But this is pure mathematics. Pure mathematics, all right? Pure mathematics. So what it is, the book derived. So just remember this. Just remember this. So this is just short notation. Short notation. So remember the second line. Could you write the Maclaurin series with R chosen n? Well, the book already write. Right here. Right here. You see? Let's go back to a little bit to see the book, the calculation of the book. You see here? We don't really know what R is, right? So R can be any number. We can use the power rule to take derivatives. First derivative, the R times 1 plus x raised by R minus 1, da 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 da. Maclaurin series centered at 0, right? F of 0 is just 1 for this case. F prime of 0, just R times 1 plus 0 raised by just R, right? Second derivative, just R times R minus 1, so on and so forth. So what is R chosen n? R choose n just this. R times R minus 1 times R minus 2, da 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 da, until R minus n plus 1 divided by n factorial. This is just Cn, right? Cn. So this is the notation. Big parentheses, R choose n, close, big close parentheses. It's weird, but it's just pure mathematics, all right? It doesn't make sense in life. It doesn't make sense. You know, you have half apple on the table, choose 5 out of half. Doesn't make sense. But don't think that way, okay? It's just pure mathematics. Just this. What is out of R choose n? Just this. Does that make sense? Paul, does that make sense? Okay, in that case, you better show me your answer sheet, because without looking at the answer sheet you were talking about, I have no idea what are you talking about. So this is just R chosen n. This is just the definition. Would you be able to share your screen with me? Oh, okay. Let's do that. Let's do that. $175. I didn't know that. I didn't know it has answers. 175. So you mean I click on this? Oops. Oh, okay. Oh, I see. Okay, so this one actually is much easier, right? So what does this tells you is the odd terms disappears because the odd order derivatives is 0. So we're left with x raised by 2n. So the even exponents survive. So the book is just being lazy. The book is just being lazy, saying, okay, I'm going to write it in shorthand. That's it. Because what's R? R is negative 1/3. It doesn't do any calculation. That's fine. Because the homework doesn't ask you to write a couple of terms. Right? If I ask you to write a couple of terms, you write in the first term just negative 1/3. Right? Second term, you do negative 1/3 times negative 1/3 minus 1 divided by 2 factorial. But you have to understand that. Right? You have to understand what does this notation mean. Okay, Paul, does that make sense? Okay. You're welcome. You're welcome. I didn't even know that the book has answers with this. Okay, that's great. Okay, so this one is just okay. All right. Anyone has any other questions? Let's see if we have something left to do with binomial series. Binomial series is very useful also, even it's not applicable. It seems like not applicable, just like imaginary number, right? It seems like weird, but it works. We share. So again, with R to be a real number, so out of R choose N, this is a definition. Okay, doesn't matter what R is. You can imagine R equals to pi, an irrational number, or square root of 2. Right? You would have square root 2 multiplied by square root 2 minus 1, multiplied by square root 2 minus 2, so on and so forth. Then divided by n factorial. Okay, so this is a pure mathematics. Okay, let's finish this one. So we want to evaluate square root of 1.5 by using the first 4 terms. P3 means, take a third order derivatives, which is function value, first derivative, second derivative, and third derivative. So we just plug into this, where we have 1 plus half x minus 1/8 of x squared plus 1 over 3 divided by 3 becomes 1. So we have 2 factorial. So 1 over 2 raised by 4, which is 1 over 16 x cubed. Right, so we have these 4 terms. So this is the third order Maclaurin polynomial, right? To approximate this function. So now we can use it to approximate square root of 1.5. Right? We can write as square root of 1 plus 0.5. So x is just 0.5. So plug into P3 of x. So 1 plus half times 0.5 minus 1/8 times 0.5 squared plus 1 over 16 times 0.5 cubed. Put into calculator give us a value. So that's about 1.2266. Okay. Anyone has any questions? So this looks like an exam question, all right? To find a binomial series for a function, then to approximate, some value. Actually, you know what? Let's try this one. Everybody, let's try f of x equals 1 over 1 plus x squared. Let's use a couple of minutes to try this one. So that's 1 plus x raised by -2, right? So r is -2. So I'm going to check attendance. Okay. Anyone? You could write it in short notation. Oh, okay. Paul has it. 1 minus 2x. Shahaya has -1 raised by n times n plus 1 x raised by n. Okay, the factorial disappeared. Okay, actually, let's try this one. Let's try this one together. I'm not sure myself too. So we have f of x equals to what? What was it? 1 plus x raised by -2, right? Yes. Okay. So all we have to do is just follow the definition. Oops. So we'll write n start from 0 up to infinity. We have -2. Choose n. -2, choose n. X raised by n, right? So let's write down a couple of terms. So the first one would be -2. Oh, let's not write down like that. So this first one would be -2 to -2 -2 divided by 0 factorial x raised by 0. Just -2, right? Just -2. But if we want to write, so the second one would be -2 times -2 minus 1 divided by 1 factorial x raised by 1. Then let's write the third term would be -2 times -2 minus 1 times -2 minus 2 divided by 2 factorial x squared, right? And if we don't, let's do more. Then we have -2 times -2 minus 1 times -2 minus 2 times -2 minus 3. It's all divided by 3 factorial. Then x raised by 3. Okay. So let's just do 4 terms, right? 4 terms. So is equal to, the first one is -2, just r, right? The first one is just r. The second one is just r times x. So minus 2x. Right. Hold on, it's not right. So -2 minus 3 divided by 1 factorial. that's positive 6. Let me just go back to the definition to make sure. Oh, hold on. Right, the first one should be 1. I made mistakes. The first one should be 1. Okay, this is a mistake. You see, I don't even remember myself. This is a mistake. This is just everything raised by 0. So this is just 1. So this is just the first term is just 1. So basically, let's try to. Let me just go back a little bit. Okay, let's ignore anything else. Let's just use this one. All right, ignore the 6.9. Use this one. So 1 plus x raised by r. R can be any real number. That equals 1 plus rx plus r times r minus 1 divided by 2 factorial x squared. All right, let's use this one. So we have 1. The first one is 1. 1 plus rx. Well, r, let's write r. R equals -2. Right. So 1 minus 2x. First two terms. The third term is r times r minus 1 divided by 2 factorial. R times r minus 1. R times r minus 1 divided by 1 factorial. Right, but this is a 2, second term. Right. So first term, so 1, then plus rx. One plus rx, then plus r times r minus 1 divided by 2 factorial. Divided by 2 factorial. Right. Then do the third term. The third term, so this 2, this is 3. Divided by 3 factorial. Right. So this will be r times r minus 1 times r minus 2 times r minus 3 divided by 4 factorial. X raised by 4. So we have 1 minus 2x, then -2 times -3, that's positive 6. Positive 6 divided by 2, that's 3, plus 3x squared. Oh, that's what you have. That some of you have, right? So then this positive 6 times -4. Oops. 3 factorial is 3 times 2, which is 6. Simplifies this. So I have minus 4 x cubed. All right, you guys did it much faster than me. So -4, so all this divided by 4 times 3 factorial. And 3 factorial cancels with this. So we have -6, no, -5, -5. Are we missing something? So this is, so divided by 3 factorial, this divided by 3 factorial, we get -4, right? So we have -4 divided by 4, that's just 1. So 1 minus 2x plus 3x squared minus 4x cubed. All right, that's enough. Let's not do any more. And this is -5, so I have -5. So -5. So let's do one more. So plus negative, negative, positive. 4 divided by 4 is 1. So plus 4x raised by 4. Okay, let's just do this couple of terms. Then let's see the pattern. What's the pattern? The pattern looks like, okay, positive, negative, positive, negative, positive, negative. So the first one is positive. So we want to do negative 1 because we start with 0, right? Negative 1 raised by 0 will be positive. Then, so the coefficient will have 1, 2, 3, 4. Every time just adds 1. So negative 1 raised by n. If the first one is 0, but we have 1 here, so we have to do n plus 1. Right? So n start with 0. So 0 plus 1 is 1, we get the first term. The second term will be 1 plus 1, we get 2. And negative 1 raised by 1, that will be negative. Right? Then with x term, well, we have x raised by 0, x raised by 1, x raised by 2. That's just xn. All right, so this one, the an's term is just negative 1 raised by n plus 1, x raised by n. Well, that takes me a while. Anyone has any questions? Okay. I think you guys are much faster than me. Okay, all right. It's just memorizing the formula, that's the problem. Yes, I agree. So r plus 1 plus rx plus r times r minus 1 divided by 2 factorial x squared plus da. I agree, but you are young, you know. You still can memorize stuff. Okay, let's see if we need to talk about this. Okay, common functions expressed as Taylor series. Damon, you're not young anymore. You're still young. People are saying, you know, if you're not reaching 60 yet, you're still young. So I'm also young. All right, we are all young. Okay, so f of x equals 1 over 1 minus x. Maclaurin series centered at 0. So it has this representation. Interval of convergence is this one. E to the x is the x raised by n divided by n factorial. Right? You see how interesting this is, right? So 1 over 1 minus x and the e to the x are totally two different functions. But the representations in Maclaurin series is just so similar. Just 1 divided by n factorial. That's the difference. Sine x has this representation. Cosine x has this representation. ln1 plus x has this representation, right? Arctangent, this representation. 1 plus x raised by r. So now we have new definition of r choose n. R choose n for r to be real numbers, we have new definition. So that's the new definition. So the new definition, I don't even remember. I think I remember just this. R times r minus 1, until r minus n plus 1 divided by n factorial. Right? So this is a new definition for r to be any real numbers. So, you know, those are some good functions to make a correspondence with. Okay, Deriving Maclaurin series from known series. So we want to find out a representation for f of x equals cosine square root of x. Let's ignore the sense. So we want to use Maclaurin series for cosine x, right, to derive for cosine square root of x. Then we use, okay, so -1 raised by n, x raised by 2n now, because that's cosine x. Remember cosine x, right? -1 raised by n, x raised by 2n. But now x for our case is square root of x divided by 2n factorial. So we just plug in x, square root of x for x. So we just plug in square root of x for x because the angle is the square root of x. Right? Well, square root of x raised by 2n, just x raised by n. If you want to write a couple of terms, so that's it. Okay. Let's talk about sense. So if we talk about sense x has this formula. E to the x minus e to the negative x divided by 2. So we know how to write out e to the x, right? E to the x is just this, x raised by n divided by n factorial. So x raised by n divided by n factorial, the minus, now x is negative x raised by n divided by n factorial, right? This is plus. So we use this 2, we combine them. So we get something like this. All right, let's use this. Well, sine x squared, as we can imagine, we just use the representation for sine x. Now x is x squared, right? So that will change to be x squared, then raised by 2n plus 1. So that would be x raised by 4n plus 2. Right, so sine x squared representation is -1 raised by n, x raised by 4n plus 2 divided by 2n plus 1 factorial. So that's like an exam question also. Okay. Differentiating a series to find a new series. Use binomial series for square root of 1 plus x to find the binomial series for 1 over square root of 1 plus x. And the second one is the square root of 1 plus x raised by -1. Well, let's see. So when we take derivative of square root of 1 plus x, we get a 1 over 2 square root of 1 plus x. So that means we can take a derivative of this series representation. So that means 1 over square root of x equals 2 times derivative of square root of 1 plus x. So we take a derivative, so square root of 1 plus x, we just did somewhere. Right, we just did over here. We just take a derivative of this. Derivative of 1 is just 0. It's gone. But then derivative of this inside, take a derivative of this in terms of x. In terms of x. So what do we get? We get n times x raised by n minus 1. Right? Then n simplify with n factorial. So nothing changes, but n factorial becomes n minus 1 factorial, and x raised by n becomes x raised by n minus 1. Right? That would be, oh, we also have 2, have the offset with 2. Then we have 2 raised by n minus 1. So that would be the representation for 1 over square root of 1 plus x. So we use this one, take a derivative of this one. We take a derivative in terms of x, not with n. Okay, not with n. N is not a variable. The variable is x. So 1 over, so take derivative of that. It didn't take derivative, I don't know why. It should take derivative of this, right? All right, so that's about binomial series. So I want to go into chapter 7 today. Anyone has any questions? If not, let's go to chapter 7. I want to get into chapter 7, talking about parametric equations. Okay, let's see this. So what do we want to do? We want to plot a curve described by parametric equations. We want to convert parametric equations of a curve into a form, a function form. And we want to recognize parametric equations of basic curves, such as a line and a circle. And we want to recognize the parametric equations of a cycloid. Okay, let's read this part. In this section, we examine parametric equations and their graphs. In the two-dimensional coordinate system, parametric equations are useful for describing curves that are not necessarily functions. Okay, so this is the reason why we want to even talk about the parametric equations. So basically, it's just another structure, mathematical structure. What's the advantage of it? Think about a circle, right? A circle is not a function. A circle is not a function. We can cut in the middle. We can talk about two functions. Both semicircles are functions, are two functions. So we can use parametric equations to talk about the circle. So how do we talk about it? We talk about it as, you know, circles, just those points, right? We have x value, we have y value. And we can define x value as a function in times of t. So just consider like an ant, you know. Imagine we have a curve. Imagine we have an ant. The ant make a trajectory. So the ant crawling in a perfect circle trajectory, right? So at each moment, the ant is at a point, has x value, has y value, and the x value, we want to make x value to be a function in times of t. And we don't want to make y coordinates also a function in times of t. So in this case, and we call this trajectory parametric equations. Not equations yet. Okay, so x of t, y of t is a point of this trajectory. And we want to use x, y to make parametric equations. So let's see this one. So this is ellipse. So we have this ellipse. And each point has x value, has y value, and we want to write x value in terms of time, y value in terms of time. Okay, so this is the definition. If x and y are continuous functions of t on any interval I, then the equations of x equals x of t, and the y equals y of t are called parametric equations, and t is called the parameter, right? So t is a parameter. Well, t is a variable for y, t is a variable for x. It's called the parameter. The set of points x, y obtained as t varies as time goes on. Varies over the interval I is called the graph of the parametric equations. The graph of parametric equation is called parametric curve or plane curve, and we denote it by C, curve C. So you can imagine what's parametric equation. It's just a set of points. So the x value is a function in terms of t, and y value is in terms of t. Let's see this graph. Graphing a parametrically defined curves. So x is defined as t minus 1. Y is defined as 2t plus 2. Right? And t is in between -3 and 2. So we just evaluate some values, right? T from -3 up to 2. We just pick a couple of values. Then we evaluate x of t. So x of t, we get, according to t, we get x of -3, x of -2, x of -1, x of 0, x of 1, x of 2. Get those values according to how x is defined. X is defined as t minus 1. Right, t minus 1. So t minus 1. T -3 minus 1 -4. -2 minus 1 -3, -1 -1 -2, so on and so forth. And y is defined as 2t plus 4. 2t, 2 times -3 plus 4, -2, so on and so forth. Okay. So now get a bunch of points. Get -4, comma, -2, -3, comma, 0, -2, comma, 2. Then we can graph. So when we graph, we see this. We see this is a straight line. Isn't this interesting? And of course, we can represent this straight line as a function. As a function. As a function, we will get f of x equals some mx plus b form. With the parametric equation, we have open parentheses x of t and y of t. Or we do open parentheses t minus 1, comma, 2t plus 4. So parametric equations is misleading because it's not an equation. It's not an equation. It's not an equation we used to talk about it has equal sign, right? But it is an equation in this sense. X of t equals something, y of t equals something. We can think of this as two equations. But the representation is, let me type in the chat. So the representation of this parametric equation will be t minus 1, comma, 2t plus 4, where t in -3 to 2. Okay. So we could represent this way. And a lot of times, because this is it's a quick to write this way. So it looks like, it doesn't like an equation, right? If we write the open parenthesis t minus 1, comma, 2t plus 4, close parenthesis, it doesn't look like an equation. But however, we call it parametric equation because of this. Because of x of t equals t minus 1, and the y of t equals to 2t plus 4. Okay, so the name comes from x value, it's a function in terms of t, it's an equation. And the y value is y of t is in terms of time, in terms of t. Okay, is this okay? Am I confused, anyone? All right. Anyone has any questions? Okay, let's see circles. Okay, let's see this one. So this one, x of t equals t squared minus 3, y of t equals 2t plus 1, t goes from -2 to 3. We can do a couple points, then we can graph. So the graph looks like this. And of course, we know this is not a function, right? It's not a function. But it's a parametric equation. Okay, let's see a circle. Circle is a bad example. Okay, for circle, x of t, we can, okay, this is not a unit circle. This is a circle centered at the origin with radius 4, right, with radius of 4. So we get x of t equals 4 cosine t. T in this case can represent the angle, right, represent the angle. So x of t equals 4 cosine t, y of t equals 4 sine t. So we know circle is not a function, so we can represent it with a parametric equations. X value is 4 cosine t, y value is 4 sine t. All right, let's try this one, 7.1. Sketch the curve described by these parametric equations. So x of t equals 3t plus 2, y of t equals t squared minus 1. T goes from -3 up to 2. So just evaluate at the integer points, right? -3, -2, -1, 0, 1, 2. Then graph those points and connect those points to see what you get. All right, let's try this. So I'm going to try myself this time. What is it? The parabola, upward parabola? What do we get? So later on, we're going to talk about change this parametric equation to some functions, or some functions can be written as parametric equations. Looks like a broken parabola, but why wouldn't it be a function? Or some of them are functions. Some parametric equations are functions, but sometimes they're not functions. Yeah. You see, if we do this one, x comma f of x, this will be always a function, right? This looks like a t f of t, or even thinking identity function, so x of t is t, right? Y of t. You see, functions are always parametric equations, but the parametric equations are bigger set, may not be functions. Okay, great. Let's see more. Eliminating parameters. What happened? Okay, eliminating the parameters. So let's see this example. So x of t equals t squared minus 3, y of t equals 2t plus 1. So we'll have x is a quadratic equation. So y is a linear equation. T goes from -2 to 3. So solving the second equation for t, so from the second equation we get t equals y minus 1 divided by 2. Then we plug in t into x, right? So x of t now becomes x of y minus 1 divided by 2. So we just get y minus 1 over 2 squared minus 3. We simplify, get a y squared minus 2y minus 11 over 4. So we can think of this, function x is a function in terms of y, right? So x is a function in terms of y. So by doing so, we eliminated the parameter t. So we can do this. So the graph of this function is a parabola opening to the right. It's not a function, so y is not a function of x. But we can consider it's a function of x is a function of y. So we have this kind of parabola. Well, let's see a better example. So let's see, so here we have a x of t equals square root of 2t plus 4, yt equals 2t plus 1, t goes from -2 to 6. We can solve t from the second one because that's easy, right? Because it's linear. Then we plug into the x. Oh, okay, so this one did for x. I said x equals square root of 2t plus 4. So x squared, we square x, we get 2t plus 4. So we solve for t. So t can be represented as x squared minus 4 divided by 2. Now we plug it in t into y. So y of t equals 2t plus 1. So y of t equals y of x squared minus 4 divided by 2 now. So that equals 2t plus 1. So 2 times x squared minus 4 divided by 2 plus 1. So y is indeed a function of x. So y equals x squared minus 4 plus 1. So y equals to x squared minus 3. So y, so this is a function, right? Y is f of x equals x squared minus 3. So this equation, of course, is a parabola open upward. It's a function by convention. And we may try the other way around, right? We may try, solve t for y. We will get square root. So we solve t from y. So we will get t equals to y minus 1 divided by 2. Y minus 1 divided by 2. Then we substitute into x of y minus 1 divided by 2. Then we have 2 times y minus 1 divided by 2. That's simplified to be y minus 1. Y minus 1 plus 4, that becomes y plus 3 square root. Right. So it depends on which one. So we would get x equals to square root of y plus 3, or which is similar to this, not exactly the same because we have square. That would be just half of this, right? So x squared equals to y plus 3. And that would be just a positive. So when we square root of x, we get a plus minus square root of y plus 3. So that would just give us the positive ones. Anyone has any question? So that's the graph from -2 to 6. That's the graph. It says sometimes it's necessary to be a bit creative in eliminating parameters. The parametric equation for this example are x equals to 4 cosine t, y equals to 3 sine t, ellipse, right? So you see, for x, it's 4 cosine t. For y, it's 3 sine t. So one is 4, one is 3. So we know that's the ellipse. So what we could do is we could write cosine t equals x over 4, sine t equals y over 3. And we know cosine squared plus sine squared equals 1. So we can write x divided by 4 squared plus y divided by 3 squared equals 1. And then we see we get an ellipse. Okay, parameterizing a curve. So this, we are starting with a function. And we want to write x in terms of t and y in terms of t. So in this case, because it's a function, we can always do this as I wrote before, t f of t. Okay, we can always do this for functions. So the first one, x of t just equal to t, identity function. So we just define x to be t, identity function. So of t just change x to be t. So this is t f of t basically, or t y of t. You know, so a function is always parametric equation. For the second one, yeah, that's it. That's it. So we would write open parentheses t, comma, 2t squared minus 3, close parentheses. Or we can write it like this. We can write as two equations. Okay, I'm going to leave cycloid for next class. Let's practice. Let's try this one. So eliminate the parameter t. So write y in terms of x or x in terms of y. Depends on from which one we solve a t. We can write two equations, right? And these two equations will be inverse with each other. So try to write in two ways. Try to write we could write t y of t or x of y, right? That would be one representation, or y of x. Okay, Damon has, well, you can solve the y for t, so t equals y plus 1. Then plug into x of t equation, so x equals 2 plus 3 divided by y plus 1. Yes, exactly. Golem says I can solve t from x, right? So t equals to 3 divided by x minus 2. Then I plug into y, x of t, y of t equals to 3 over x minus 2 minus 1. Then simplify. Okay, Golem, I understand your first one. Y of x equals 3 over x minus 2 minus 1. X, oh, okay, I see what you did. You get a y plus, so 2y plus 5. All right, you combined, you make a common denominators, I see. Yes, that's it. Okay, anyone has any questions? Yes, that's to eliminate parameters. Okay, we still have a couple minutes. Maybe let me see if I have enough time to talk about cycloid. Cycloids and other parametric curves. All right, so this is, so x of t equals a times t minus sine t. Y of t equals a times 1 minus cosine t. All right. Or x of t equals at, y of t equals a, or x of t equals negative a sine t, y t equals negative a cosine t. Or we have this bunch, right? So cycloids. So we can imagine we have this, you know, a wheel. This wheel keeps running on the road. Think about a tire for a car keeps running on the road. So if we mark any point on the tire, on the wheel, right, we see the point keeps running so the point makes a trajectory. The point makes a trajectory as this wheel keeps going on forward. Makes a trajectory, and we call this trajectory a cycloid. All right. So this is saying x of t equals 3 cosine t plus cosine 3t. Y of t equals 3 sine t minus sine 3t. Wow. You see how fancy that is? Okay, the general parametric equations for hypercycloid are those. And I'm not asking you to remember this. So this is a minus b cosine t plus b cosine a minus b divided by b over t. So basically, x is a function in terms of t. All the a, b's are some numbers. Y of t, a function in terms of t with sine involved, cosine involved. But with sine, cosine involved, we know we get these smooth curves. And when a over b equals different, I don't know what was going on, equals different numbers, we get different pictures. Okay. It's beautiful, right? See, this is beautiful. the ratio of A of B equals to pi. See how beautiful? So people studying this stuff. Okay, we're not doing project for this. Okay, so I'm not going to give you homework. Cycloid is just for us to know. All right, just for us to know. A lot of study can be done with that. So I'm going to assign you some homework with the parametric equations. All right. Okay, that's it for today. Anyone has any questions? All right, have a good night and see you next week. Have a good weekend. Thank you. Thank you.